Thank you, thank you. So without further ado, our panel this evening, On-Prem and Cloud, both worlds for HPC. Our moderator tonight is Brock Taylor from Intel. Let's give everyone a warm welcome.
Thanks, Randy. Who do you see? What kind of users are coming in? What are the ones that are already taking advantage of HPC?
Thanks, Brock. It's, I guess, refreshing to see the analysts catch up with almost where reality's been for a while. I think many of us sitting up here wondered when their estimates would start to show a little bit of what we've seen from our customers successfully migrating workloads to the cloud. We see a vast array of workloads that are starting to migrate from your more traditional high throughput computing, which didn't require as tightly coupled, that low latency interconnects, to now we've got customers with our new EFA Elastic Fabric adapter with our low latency interconnects that have started to move more and more of those kind of seismic workloads, things that people would even say are a little demanding for on-prem, such as weather codes that we've been, I'd say, pleasantly surprised to see how they perform in ourselves on the hardware. So it's typically pick your favorite HPC codes, CFD, CAE, EDA. All those workloads are starting to migrate.
Karan, what about you?
Yeah, I couldn't agree more. I think it's interesting. I've been coming to Supercomputing meeting for a while now, and every year it's like, this is the year of the cloud. This is the year. A couple of years ago, it was like, yeah, we're thinking about it. I think from a customer standpoint, what I've seen talking to customers is, a few years ago they were like, well, is it possible? Is it not possible? A few years in, it was like, well, we have a hybrid strategy. Now, I think customers are coming in and saying, we have a multi-cloud strategy. We are going to run this stuff with all cloud providers, help us move this to the next generation. I think one thing Ian touched on is hardware innovation, right? They really see the ability to go to the cloud to essentially compete with other providers and other organizations, right? They want to run their designs faster. They want to run their simulations faster. I think they really realize now that the business value that they're providing to their customers is building a better car, not managing the infrastructure under the covers. I think that click has really happened. And I think now we're starting to see customers really move to the cloud before HPC.
Yeah, I noticed you had actually written a little bit about some crash code testing and things that have been done. So
yeah, exactly. I think even the ISV ecosystem, right? I think they've now sort of come along the lines when it comes to licensing, and they've sort of relaxed their regulations around like where you can run licenses. It's okay to go run in the cloud. It's not an uncertainty anymore.
The adoption that we see, you can organize it by sector, by activity. It's the usual suspects that you might imagine. People who have big community problems, the energy sector, life sciences, all of these things. But I think that what's bringing people on the cloud, there's the first group of adopters, and not because they explicitly want to do HPC in the cloud, but because they want to manage the information and compute globally in the cloud, because all the advantages of that confers. And when these operations also happen to have HPC workloads, it becomes sort of a no-brainer. That's all part of the basket to make that work. So the early adapters are the big picture.
Yeah.
And now we're seeing people specialized working in, I have busy loads, I cannot afford to upgrade my hardware as often as the cloud company upgrades their hardware. And we're seeing people doing for its own sake now, as opposed to as part of a larger package.
Yeah, and I think we actually, the talk that was just before us was talking about genomics, and I think that's something you're seeing a lot of that's potentially very well suited to the cloud and being able to use it, leverage the cloud.
Not to brag, but Broad Institute, which is the largest sequencing shop in the world, has the whole operation running on the cloud test for several years.
Yeah, and we also do a lot of work with them as well. So being able to bridge some of those local resources as well, and know that you've got that ability to go to larger data sets, a little more expansive. So yeah, it is very interesting. Thor, what about you?
Yeah, so we have definitely been seeing a lot of success with traditional first users going to the cloud. They are very impressed with the performance that they deliver. Thanks to our user for the internet and that as a service. We are able to deliver this kind of traditional customers in the cloud environment.
Yeah.
So we've been seeing a lot of engineering firms, CFD, Massachusetts.
Yeah, you just had a big CFD win, right? A pretty
Yes.
major element.
We just sent the launch last week.
Yeah, awesome. So, even with it becoming bigger and bigger and seeing the ramp, you still hear a lot about people kind of not trusting the cloud as much, right? There's still those elements. So I'd like to understand, how are you addressing those questions that you're probably still getting a lot about concerns over data management, data movement into and out of the cloud, security, and those things. Are you still hearing those concerns when customers are trying to connect? Go ahead, Karan.
I'm happy to take this.
Yeah,
but
go ahead.
I don't want to hog the mic. Well, any responsible customer is going to have those concerns on their checklist. Clearly, but some of these are legitimate problems, and some are perception problems. In terms of data security, data in Google Cloud is as secure as anywhere on the planet that is connected to the internet. We take this very seriously, and we have to. So, the security of the data is really not much of an issue once the customer actually understands how we do things. One does have issues in terms of having to be clever how one works, because there is a cost to move data, but the costs are variable. And so if one takes a naive model, that this is what we have to get past, people coming in and say, well, wait a minute, this means I'm going to have charges like this to do my job. And yes, that may be true if you do your job unthinkingly, but with a little bit of intelligent management, this can be kept to a lower roar. And things are, of course, negotiable as well.
Yeah.
But it's all part of it. There's a broader scope of how you think about the economics of working with the cloud that we'll touch on. But this whole notion of where is the data, moving the data, it's a checklist item. It's a legitimate concern, but I don't think it is a problem.
Yeah. Anybody else?
Anything different?
From our standpoint, it's quite similar in that if you stay with the workflows that you're doing today on-prem, yes, can we fully support you in the cloud? Definitely. But are you doing the most cost advantageous optimizations to the way that you do work? No, you're not taking advantage of the additional capabilities that you get from being in a fully elastic environment. Just for example, being an old Lustre guy, we used to stand up petabytes of Lustre storage, and that's what you stood up, you ran it until it crashed, and then you started over. Here, with our Amazon FSx for Lustre, it's fully dynamic. You spin it up, run your workloads, hydrate some data from S3, compute what you need, save the results off to S3, shut it down. I mean, it's a different way of thinking about work. If you want to take advantage of the capabilities that you have in operating in a cloud model, it's just a different way that you have to start looking at re-architecting your workflows to fully take advantage of those cost optimizations.
Karan, I don't know if you run into it. Do you get people that they come in and think, I do have to re-architect my workloads? Or are a lot of things running out of the box and just shipping the workloads?
Yeah, I think I think partially I definitely agree with Ian. I think we at Orb have a little bit of a different point of view. I think a lot of people say lift and shift, right? Our sort of motto is moving forward. Now, why is it their responsibility to re-architect right now? Eventually that will happen, and maybe it's their decision to do so. But I think what we've tried to sort of say is it's our responsibility as a cloud provider to make sure that we have the things that help them move, right? That lowers the barrier of transition. So that means, as an example, bare metal, right? I run my data center, I run a bunch of clusters, I want to make sure I have the same performance. So I think, going back to your point about security, I think we get less concerned about security, as was said. There's more concern about performance, but also stability of that performance. I'm going to spin up a VM, am I going to get the same performance every time, with the same code that I'm running? Do I have to go change my API stack to be able to re-architect on the cloud? So there's lots of different questions, and that's what gives them uncertainty and worry. And what we've tried to do is make sure that we have to be at least the same or better than what they already have today on-prem. And that's really the value of the cloud, right? So we've tried to sort of emulate as much as possible as to what they have today, and potentially provide them value in the future when they can take components of their workflow and modernize. Maybe instead of running whatever IP you want, maybe we use Terraform for orchestration or whatever it is, right? So it's more about moving it and then modernizing your workflow in the future.
So what we have been doing is basically talking about HPC as a service. To basically ready-made templates or HPC clusters that can to address the common needs that we see with multiple users. So then we are bringing our best practices or things we have learned and seen very important to the users of the systems and making it into a solution.
So one of the things that we hear a lot is people are using it in bursting and handling surge peak, or peak surge. We've heard some, call them anecdotes or stories, where they've actually turned on connections and used the cloud, and when they do and they turn it over to the engineering teams, all of a sudden they're running up the bills. So talk a little bit about what you're offering or what your thinking is in terms of helping people cost manage how much you're putting into the cloud and how much they know and how much you can actually show them, here's your usage over time. And so they, again, we're talking about control over where those workloads are running and how much people know what they're doing, and they really give fine-grained control over those workloads. So if you could talk a little bit, I think that'd be a very interesting part of it.
Sure. I think this is kind of standard Cloud 101, right? If you're a provider, I think it's your responsibility again to make sure you provide the right controls and feature sets. I think a lot of the cost maturity comes from understanding what resources you're running, because if you give something like the cloud direct access to a designer or scientist or a data science person, they're going to go crazy, right? It's going to be a playground for those guys, right? So I think you have to have those controls in place, and some of the things that we're working on is governance models where you can federate your identities and those have policies attached against them. And we're not just doing that at Oracle Cloud, but we're doing that across multi-cloud with a partnership we announced with Microsoft as an example. So what you can potentially do is put limits. You can put dollar numbers, you can put core numbers, you can even do job-based quota limitation, right? And it really comes down from what are the policies you have on-prem today, how are you going to map them to the cloud, and sort of control access, or at least educate your users, right? And really it's about education, because once they familiarize themselves with the tool set, I think they can better utilize the resources, right? In fact, you probably get better utilization out of those things as well. Right now, on-premise, whoever comes first gets it, and they go crazy, right? So I think it's more about education. The tool set, I think it's all monitoring, quality management, governance, controls.
I think with AWS Cost Explorer is one of the most frequently tools used by our customers, as well as coming to our booth, one of our partners, Ronan, has developed a really unique solution to where you can not only monitor what your costs currently are as compared to your budgets, but you can actually do predictive modeling of what would this job cost to run. And then you can have, as far as how that's allocated across accounts, is this enough? Am I going to overrun my budget? Do I need a flag approval to allow this job to even be scheduled? And to give you that sort of control to your users, I think ultimately is what you want, because to be honest, I kind of like the idea of scientists going crazy. I like the idea of engineers going crazy, because, and I get it, we want to ensure that it's within limits and we want to control the spend and all that, but honestly, why did any of this even start? Because people wanted to think crazy things. They wanted to do crazy research. They wanted to imagine the unimaginable. And that's when we get really interesting things happening in science, is when scientists and engineers are working on virtually unfettered resources. And then, yes, we all, at the end of the day, we have to figure out how to pay for it. We have to figure out how to constrain it. But if in the back of their mind, they're thinking, I don't know if I should submit this job because, who knows where it's going to end up running and how much it's going to cost. I mean, yeah, we need to have those value discussions, but honestly, that's a discussion we should be having on policy level. Let's set those policies, whether it's on-prem or in the cloud, and let's stop with this I'll say, anachronistic scheduling model we have of large jobs versus small jobs versus various priorities that are set by some sort of a board, and let's figure out what the real value or potential value is to the endeavor, whether it's a company, whether it's a research institute, what of that job, and let's give a little freedom to the users. That's where I get excited about this. Is like having research or engineering driven compute. That's what makes me excited about the advances of HPC.
Yeah, and I like to say it's not what we know people are going to do with HPC, it's what we don't know that they're going to do with HPC. And cloud has real potential to turn a lot of new people into this field.
The problem is global to a cloud provision model in general, which is to say, as long as if it's pay as you go, then you have to pay much more attention to what you're doing in general. It becomes particularly exciting for HPC because people are running parallel codes at scale. They're consuming a lot of compute in a very short period of time. So, needless to say, we have all kinds of tools to allow people to monitor and watch their flows, set limits, and all that. But those are reactive, and that's fine. What you really don't want to have happen is you don't want to have. I have these big jobs I'm running, and I have my big job that is partly completed while it's set up, and I've run out of quota, and I get starved. So you need to be able to anticipate, you need to be proactive. And so among other features, our tools allow you to set up publication events. We have this, for those of you who don't know Google Cloud very well, we have this wonderfully scalable hub subsystem, as we call it, for managing events. It's useful for many, many things. You can build a schedule around it, and people have. But one of the things that you can do is you can have publish events that I have hit this high watermark of my consumption, where I know that in this, I can have this automatically send an email to an alias of researchers or whatever to warn them that, please don't start another big run until we've gotten to the next level. It's a global problem. We've had to develop tools. I can tell comical anecdotes of the early days of cloud when we didn't have these things in place. But this is pretty well managed. The key is to teach people to be thoughtful and have proactive tools that can push people to be thoughtful when they forget.
Well, I confess I have started up an instance, got kind of interrupted, gone to a meeting, and somewhere near the end of the meeting realized that I did not shut it down. And so the panic that ensues can be quite adventurous.
If you were a true scripter, you might have just written something that said, "Oh, and if I forget, spin this down," because you can't automate that.
Yeah.
I mean, if I could address one thing you started with, because I think it's important in terms of cost management and this whole opportunistic bursting model. There is a somewhat the naive model of how one bursts to cloud is that I have a certain amount of capacity across all these applications and all these groups, and if I run out, I'll just send that work to the cloud. And when you do that, you get to the situation that you're talking about, where the individual scientist or researcher fires up a job. He doesn't know if it's on-prem or in the cloud, and so he may be less careful about it. And in general, you have to replicate data back and forth if it's a mix. So in general, I consider best practice for bursting is where you do it kind of sort of by a project on a relatively low unison. So if it's the time of the month where a particular job is going to take too much on-prem, you pick your cloud-friendly applications, you just sort of migrate that for some duration into the cloud. So it's a low-frequency bursting. And if you burst the whole project, everybody who's working in that project is standing in the same place and playing by the same rules.
Yeah. Jon Thor, did you?
Yeah, so I guess our customers are a bit more traditional. They prefer no limits and no spend. So we definitely utilize limits and just try to get the most performance out of what they are willing to spend. And if they see the budget increase, we will just increase the limits and our system at that time to get even better performance for what they are able to buy.
Yeah. So it does, a lot of the answers, a lot of the conversation does have still some sophistication in the user that's familiar with HPC. I think as we're turning more people on, I think it's going to be important because, somebody may not know how long their job's going to run. So are you guys thinking about that?
Yes, we've solved the hauling problem.
Excellent. I mean, do you get that now? Do you get users that come in and actually start questioning you? Hey, you're asking me how long this job's going to run, but I don't know. Do you have that now?
Well, that's why we can do profiling with them to help them with that. And honestly, when we have different accounts, depending upon the level of the account, we're not going to brand new person just created their AWS account. Me, go spin up a million cores.
Yeah.
Okay? So they have to have a demonstrated capability and consistency of payment and ability to understand the resources that they're utilizing before we'll kind of open the floodgates.
If they promise to pay Bitcoin, is that kind of
especially if they're trying to mine the Bitcoin
Right.
that they're then going to pay us with, I frown upon it.
Yeah. Well, so we surveyed. A lot of people are thinking, how do I do it? So I'd like to kind of spin it to, what's the advice that you have for new users? You've got a lot of people coming in, and they're asking you, what's the best way? And I think you started to hit on it. I was afraid you were looking at my questions ahead of time. But what's the best workload to move into the cloud? They've got a host of things that they're running on premise. What do you tell them? Where do you tell them to start?
For me right now, the best workload to run in the cloud is the workload that right now you're not doing. I mean, that's why would you, if you're happy, if you're performant, if you're never blocked, if you can always get the time you need on-prem, why would you think about migrating that right now? What I would rather see, just as an end user, is migrate the ones that aren't getting done. Unblock the researchers that aren't able to get their job done. Unblock the poor PhD student that's waiting for the holidays just so that their job can run. I mean, that's what I'd say, is unblock those workloads that are waiting in a queue to be executed. Start migrating those right now, and then let's talk about over time what makes sense to migrate when from your existing workloads.
Yeah. Jon Thor,
Yeah, so as our clusters are very similar to on-prem clusters, I would say most of the on-prem clusters or jobs that run on on-prem clusters would fit our solution.
Yeah. What about you, Karan?
Yeah, I think for most of the customers that we speak to, the jobs that they want to move to the cloud are the jobs that, kind of copying me in a little bit here, but essentially the jobs that they can't run on-prem or they can't run on the cloud, right? So either it's technology that's blocking them, whether it's a CRM2 type of hardware, whether it's a certain type of technology that's blocking them, either that or when they're essentially, stuck in a cycle or a rut of buying on-prem hardware, and now they're not going to get their budgets opened up for another 3 years, right? So I think those are the workloads that are going to be the ones that are going to move to the cloud, and where we're sort of focusing on our side is customers that are saying, look, I want to use the cloud, but I also want to have flexibility in terms of, yes, I want to have flexibility on the cloud, but I want aspects of my on-prem environment and characteristics. I want to be able to have guaranteed availability. I want to be able to have predictable performance. So that's the thing that we see. And those are the fragile ones, like some of the CFD cores, like Advania and some of the others. And those are the ones we're seeing a lot where they're churning through lots of cores and they want to be able to run multiple of those over time. We're seeing a lot of progress in that space.
Yeah, you brought up the environment. I think that's a good question. Are you getting a lot of people to come in and say, well, I want to use the cloud, but I want my exact environment. I need to replicate it entirely because, how easy is it for somebody to just connect in, right? We're kind of glossing over that HPC is still pretty hard. There's still a lot of complexity. How do they do it? How do they get in?
Yeah, we're definitely getting people. I think a few years ago it was like, well, we have a checklist. There's processor, this type of IOPS, we need, IB, or whatever else, right? Now I think people have understood what they actually want, which is, well, I want this benchmark to perform in this amount of time, and it should cost no more than X, Y, or Z. Or when people say, I want a certain technology, it's not that they want that, it's like, well, I want to be able to run my MPI codes the way I do on-prem. It's not about the actual fiber or the actual piece of physical hardware, it's more the value that they want out of that piece. And so, as an example, right, we on the Rocky route, it's IB, so people care about RDMA and being able to run their NPI, not necessarily the piece of hardware that's running in the box.
Yeah. Are you getting a lot of people coming in try before you buy kind of mentality of, hey, I want to, you've got systems I'm interested in, let me try some work, let's see how they do it. Are you seeing a lot of that interest?
Yeah, so our scenario is very similar to Oracle's. It's these understanding users, consistent companies that want the non-performance and want it to be consistent.
Yeah, and I think you guys actually did have some. They came in. You have. We're Intel, so we're going to tout the cascade, the KP systems, the 9200 series. It's a fantastic platform and processor. You've had some really good interest in people coming in and being able to try that in the cloud that wouldn't otherwise be able to do it, right?
Exactly. So these systems have twice the memory bandwidth of traditional cascade decks, and with an Intel OPA, it's pretty dramatic performance.
Yeah.
So we are definitely seeing good performance there for CFT workloads and on-cancel HPC workloads.
Yeah. Kevin, check it.
Sure, but at the risk of a direct answer to your question, okay, let's assume I'm in this position where I'm looking to move some of my workload to the cloud. I've got the mix of HPC stuff in it. How would I pick them? Okay, so several factors. If you just look at the characteristics of the job, this may sound odd, but newer codes, like an awful lot of the biotech codes, already are written around the notion of working with object stores.
Right.
And that is a primitive within the Google Cloud. You can set up Lustre and other sorts of file systems using various forms of backend storage, but our object store system is the most scalable, highest bandwidth, and most efficient way of delivering data to a large number of nodes that we've got, and one of the better ones that there is. So I would ask myself, is this application already using object, or do I need to stick a shim in place? That's a source of friction. If it's not there, that's better.
Yeah.
Another criteria would be the burstiness of this. Is its demand, does it ramp up very, very large very quickly, or is it more incremental? Because if it's going to ramp up large very quickly, then you have some coordination to do with it to make sure that your quota is supportable. If you're going to be asking at the drop of a hat for a million cores, we may or may not have them available for you. If you're going to ask for a few thousand, it's not an issue. And so it's these kinds of things that if your increments of work are in that thousands of cores or hundreds of cores and not in the tens of thousands, that's just easier to move into a cloud and never mind easier to operate.
Right.
And then finally, there's a question of what role does that application have with the overall computational work that's being done? Because if you've got something where you're doing fairly classical structural simulation, CFD codes that are, maybe that's not the most cloud-friendly application you can think of, but if your overall work is, for example, comparing that with the results of generative models on an ML-based system, where there's an in-cloud infrastructure that's very strong behind that. If the work is all coming together with other sorts of things that clouds do well, that of course makes it a good candidate to migrate.
Right, yeah. You also mentioned earlier the duty cycle, and I've heard people that have said some jobs or some of the users will go in and reserve full resources, knowing that they're not going to use them, but they have time-sensitive peaks within that duty cycle. And the cloud environment actually allows you to more pay-as-you-go for that, and so when you're in between those peaks, you're not actually spending resources and blocking other jobs. I don't know if you guys have seen that. But
Yeah, it's very cool.
yeah, okay. All right. So it's not hardball, but we're going to throw one that's a little more out there. What about people who are worried, or companies that are worried about getting locked into one cloud vendor? Right. So we are starting to hear that people are looking at it. So I'm going to come in, I want to get my environment set up, but they've got that nervousness of, I'm going to get here, and then they're going to turn around and charge me 8 times as much, tomorrow. And so they've got those nervousness. What do you tell them?
So basically for us, there's nothing really locking them to be with us. We don't use any proprietary file formats that lock them into us for our use. They are completely free to move anytime they want. It's completely normal.
When we have those discussions with potential customers, it's around expressing the value that we bring, and the fact that we've been known as the world's most customer-focused company for a reason. We seriously wake up every day continuing to re-earn their business, and we want to give them that facility, that ability to migrate wherever they want, and we want them to actively make that decision every day to stay on the AWS cloud because we've got the broadest set of services, because we've got the best service, because we've got the best options for them to run their HPC workloads in the cloud. We're happy to have that competition and happy to have them make that consideration, because we think that we will earn that business every day. And that's why we really believe that whether it's on-prem or in the cloud, that with the breadth of capabilities that we provide and the HPC resources that we have available, that our customers will make that decision to remain on the database cloud.
Yeah. Karan, did you have something?
No, I was just smiling. No, I think our take, our sort of philosophy is we were obviously late into the game, but that's allowed us to have a different perspective a little bit, which is we want to make it easy for customers. Look, we are going to live in a multi-cloud world. That is the truth, right? A big, large corporation is going to take a bet on potentially 2 cloud providers, maybe 3, right? And at the end of the day, what we want to be able to do is allow them the flexibility to be able to do that, right? We are going to do the best that we can to run their business, right? So we don't want to lock them in the sense. So as an example for orchestration, right? Well, the de facto standard is Terraform. Well, guess what? We made Terraform a first-class citizen on our platform. So if you're on a Terraform script to orchestrate your resources somewhere else, great, bring it over, it'll just work. Right? Same thing with functions. Like we have a service called Functions. It's based on an open source project called FM. You can go run that somewhere else if you like, even on-prem. So we're trying to make sure that customers are able to write code once, run everywhere, but we do the best that we can to be able to recognize it as a first-class citizen on the platform, because the value that we provide is the infrastructure, and we believe if they do that, they will see the value in itself. It's their choice. It's actually risky for us, right? Because they're able to essentially move off. But we believe our technology is so good that they're able to stay.
Yeah. I guess I'd say that, kind of sort of thank you for the lead-in. Just a slight distinction I would make. Yes, of course, we enable people to build their open source, find new open source tools of choice and build them and use them on cloud. But I would make a distinction as much, and Google is quite well known for this. We don't just support it, we push it, we create it. We created TensorFlow because the world needed TensorFlow. Okay? We created Kubernetes because we thought the world needed Kubernetes. And we open sourced it fully. And yes, it is a first-class citizen. It is a priority product for us, but it's out there. It's running on our competitors and collaborators' clouds as well. So we focus on open first and driving open, not just fun.
Yeah. Well, I can say you've made a lot of people nervous with cloud, but I think what you're seeing, what we're all really seeing, is we're realizing it's not one or the other, it's both. And there's growth in both. And I think as we started, it's going to open a lot of new doors for a lot of new people. So I think we're getting a little close to the end of the panel. And again, I mentioned hardball. It's more of the question I want to ask is, tell me something I don't know. But I'd like to just go down the line. Karan, we'll start with you, and you can just talk a little bit about anything that's differentiating about your products offering, or especially if you want to add in some success stories. I know I've actually read a number of things on each one of you that have some really interesting things. So I just want to give you a chance. Let's go down the line.
Sure. I think when we started, 3-4 years ago on this cloud journey, we all came from, most of us came from Oracle anyway, from other competitors and cloud providers, and we were able to sort of step back, and our fundamental philosophy was bare metal. We initially built it for flexibility, so if you have a 10-year-old OS, great, bring it over with Power Virtualize it, or bring your own hypervisor as an example. Right? So we were able to do it for flexibility. What we realized was we ended up sort of attracting a lot of HPC customers. Because, well, guess what? They love bare metal, so the results that they get on-prem are the exact same. Right? So I think our fundamental core was non-oversubscribed network, bare metal components and features, and then we basically built best-in-class storage with our file search service, all NVMe based, and then we tried to reduce barriers, right? So we made some decisions that are not technically different, but they're business different in the sense that lots of people, lots of customers come to us and say, hey, it's very expensive to move data out of the cloud or out of the cloud. It's great, you allow us to move data into the cloud, but when I want to move it out, it's super expensive. Well, we said, great, we pay for the port, the bandwidth is free. That's a business decision that we made because we want to encourage adoption as opposed to put barriers to hybrid model as an example. So there are decisions to be made on the technical side and on the business side.
Yeah.
Hello? Yeah. So for us, it's definitely been that we have been able to deliver performance. I mean, we are able to deliver performance similar or better to on-prem clusters. And also in terms of utilization, I mean, our focus is very strict. It's AI and HPC mainly. So we kind of know what these users are doing and what they want. And we definitely helped a lot of customers in the customer system, the standard clusters, and are also able to help them to integrate what they have already with what they have with us and make it seamless. And there are many services focused on this really. I think that's kind of where we are running.
I think two things are a differentiator for AWS specifically is while we do offer metal options for each of our components, it's the AWS Nitro virtualization that we created that offloaded virtualization onto a daughter card, providing greater security, as well as eliminating that virtualization penalty for customers that really differentiates our offering there. As well as the second one I'd say is AWS Outposts. For those of you that haven't heard of it, AWS Outposts is now your ability to have an on-prem rack 1, 2, X, and however many you want of AWS in your data center that is then connected, same control features that you'd use with AWS. We had enough customers coming to us saying, I love you, but I'm never going to move 100% to the cloud. Okay? I'm imagining many of you are thinking similar words, maybe not I love you, but I'm never going to move all my workloads to the cloud. We heard that and we said, okay. But what they also said is, I'm never going to move all my workloads into the cloud, but I'm tired of having one way of managing my on-prem environment and an entirely different workflow for managing my AWS environment. Can you please work with me to have a standardized way of doing work? And that's why we developed AWS Outposts, so that you can use those same features to manage both this on-prem outpost as well as your AWS infrastructure.
Well, in terms of differentiation, I think that, the many ways that I could describe it, what I typically do when I'm asked that question is just respond that we work with the best people in the business, for example, like Intel, in terms of delivering the technology that we develop for processing for our customers. But we don't limit ourselves to that. We are doing fundamental development in new forms of processing. TPUs won't do a lot of things that you can do on an Intel processor. They just won't, okay? But they're very good for a certain thing, and nothing else we could find was good enough, so we built it. Nobody was going to hand us a quantum computer, so we built a quantum computer. At some point, that's going to be a part of this hybrid mix that we're going to have. So that's the differentiator. We're actively driving forward and putting that stuff into people's hands in the cloud faster than they can get it another way. Now, in terms of anecdotes, I just want to drop two, because a couple things happened this week, and I think one is illustrative of the power of Google, and the other is illustrative to the power of multi-cloud. And I think they're both pretty compelling. One, we have a blog that went up on this week, but I'd encourage you people to drop by the Clemson stand and talk to them about it. We did a really cool project with them, which was a question of could we actually deploy 2 million cores for the purpose of running a specific application. And what this is about image processing. This is assimilating information from thousands of traffic cameras to be able to model what's going on in traffic during a hurricane evacuation. Because you don't want to direct people into flooded overpasses, you don't want to direct people into fatal traffic jams. You need to manage this stuff. It's a hard problem, it's a big data problem. And just to turn it into a proper big data problem, there was a processing of the raw video that was required. And the question was, how quickly would it be possible, using essentially low-rate, opportunistically acquired nodes across a large number of data centers, can we get 2 million cores up and running and useful, process a very large data set within a fixed time limit? And they pull it off. We managed to get this run going on 2.14 million cores, almost all of them in time. Although that wasn't part of the paper. Ramping it up and writing it down. Now, this was tricky. This is a challenge even for Google. They had to do this in a hierarchical model. They had to set up multiple projects, each of which had their own set of quotas, and each of which was in a different geographical region. Not that you couldn't have a multi-region project, but just the whole infrastructure worked better. There's a lot of tuning in the application to make it work, and I'm damn proud of the fact that we were able to do that. Now, in the case for multi-cloud, another thing that was, I think, published this week, I mean, I've seen it in out and about in the press. I don't know if it was actually presented here. Some of it was presented here on Sunday. But this was a project that was being done out of San Diego Supercomputing Center and UCSD, where they wanted to see how big a run they could do of GPUs. And they went to us, they went to you, they went to some other people who aren't here, so I won't name their names. And they said, okay, we want to do, I think they all went to each of us individually at first, saying, hi, could we spin up X thousand GPUs, please? And the number was large, and we have a lot of GPUs. Amazon has a lot of GPUs, but it was a big ask. So they went around, and we split the load. And so I don't know exactly what the breakdown was. I know what our share was. It was about a third. But we actually provided more GPUs for this run than are in the Summit supercomputer. So that was kind of good. Now we did beat the Summit supercomputer on flops because theirs are all quite modern. And this was including a whole range of parts of GPU. But again, this shows the HPC potential of running multi-cloud.
Absolutely, and we're going to help you guys combine forces with one API and do something tremendous that's never been done before.
And sorry to have used the G word.
It's okay. All right, well, I actually do apologize to the audience because we've actually gone a little bit over time. So, again, Kevin, Ian, Jon Thor, Karan, it was a pleasure to be up here and have a conversation with you. I really appreciate it, and thank all of you for sticking around and listening to it start to finish.